Okay, this video is to answer the questions that came up in the check-in session about the thermistor data acquisition lab, the thermistor portion of this lab. Okay, so it is true that you need to make another column that converts degrees Celsius to Kelvin. All right, so you simply add the 273.15 to every entry in the B column. So that gives you this new column. All right, and then from there, you're trying to put an exponential fit to this model that's mentioned in the lab write-up. And the model has as the x variable 1 over t minus 1 over t naught. All right, I did some poking around on that, and what that is expecting is a differential temperature where you use a certain temperature as the reference, right? So what I'm going to do here is to give a little better results is I'm going to use the first temperature in the list as a reference. I notice these are sorted slightly differently, but that doesn't matter. You get decent results this way. That's the first one. That's the reference, all right? And so when I do the 1 over t minus 1 over 298.75, of course I get 0, all right, because that's the reference. All right, so I look up here and notice the dollar signs. So I have 1 over d3 minus 1 over $d $3. Okay, so when I paste this formula down, right, so I take this and I drag this formula down like we've done many times in Excel. I notice when I look at this next entry, it's 1 over d4, and then the reference cell stays the same. Okay, so now I've got these all set up. This is going to be my x-axis, and this k-ohm column is going to be my y-axis. Now, another question came up. Well, when I do simulog plots, I'm throwing errors because of the negative values. Well, that's because you're trying to plot the e-axis, or the e column, as the y values. Yeah, and it's true. If you take the log of a negative number, log of this column, it's going to throw errors because, log of a negative number is not a real number. Okay, so this actually, E is the y-axis, and E is the x-axis, and C is the y-axis. All right, so I'm going to go over here, and I'm going to insert, I'm going to go ahead and select these, because that's just how I do it. All right, I'm going to select this, and this, and I'm going to insert, oh, hold on. Because this is the reference, you don't get very good data if you actually use that in your plot. So I'm going to start right here, and I hit Control here, or Command on a Mac. All right, I have these two things, and I'm going to insert a scatter plot at this point. Okay, and you notice the axes are flipped, so I'm going to go to here, and I'm going to select the data. All right, and what I really wanted was, instead of column, I missed the column anyway, I wanted C. All right, I wanted C to be the output, so I'm going to change it here. C is the output. I must have wondered what I was thinking. Okay, and then E is the x-axis. Okay, E is the x-axis, C is the output that we're trying to, the y-axis that we're trying to plot. Okay, so I hit an OK, and I get this plot that you can convert that to a linear or a log scale. And the advantage of that is things that are exponential look like lines on a log scale. This one happens to still kind of look like a line, even though it's not on a log scale, because there's not a lot of variation over the range that we're talking about. Okay, so I'll let you clean that up, but I wanted to show you next what to do. All right, so from here, we want to add a trend line. Okay, so I get this menu coming back up for the trend line. I want it to be exponential, and I want it to display the equation on the chart and display the R value to tell me the fit. Okay, so I move this up, and you see, here's the power of doing it this way. we're actually estimating the parameters of the model for this thermistor. Okay, so remember in the handout it said R0. R0 was 10K. All right, here's 9.7027. Okay, so that's reasonably close to 10K. All right, here's the beta value. When you make that font a little bigger, it's 6,943. It's a little bit off. You know, you expect these things to need to be calibrated with them being semiconductor devices, but you know, that's at least in the ballpark. If you throw in this initial data point, it will mess up this initial R0 value. Okay, so that's why I excluded that, to give you a little bit better results. All right, so from there, you can find beta, you can find R0. It shows you a little bit, you know, gives you a little experience about curve fitting to come up with a model for something. All right, so once I had that model for that thermistor, you know, if I wanted to use that thermistor in like an Arduino project, I now have the equation, and I could look at, you know, a different temperature, plug that in, and it would give me the resistance, or I could go the other way around. I could take the inverse of that equation and measure a certain resistance. All right, that could even be, you know, calculate a voltage, and I know the resistance value is proportional to the voltage, so I measure that voltage, convert it to a resistance, then that resistance converts to a temperature. So you can see how these things would be useful in a practical hardware system. All right, so hope that helps. Don't forget to leave off this first value using the first temperature as a reference, and make your plot from there, and you'll get a more reasonable estimate of the R0 value.